Okay, today we're going to talk about pi, what it means, and we're also going to talk a little bit about infinity and area. So, there's kind of a problem that I have my kids do on Pi Day, and I say, well, let's find the area of a circle, okay? And everybody knows the area is pi r squared, but nobody knows what that means. Okay, so the area is really how much space the circle fills. And so you could find the area of a circle by making a grid, right? Putting it on a grid and counting up how many squares are in there. That's the area of a circle, right? 1, 2, 3, 4, you count it up. Or make rectangles. And that's really, really boring, but it's doable. You can find the area of a circle. And so instead of doing that in our geometry class, well, we know about polygons. So you could put a polygon in the circle like this, right? And if you had a regular polygon, you could maybe find the area of one triangle and then multiply it by the number of triangles. So just to be clear, if I had a circle right here and I put a triangle in it, you could see the area is less than the circle. Could do one with the square and the area is a little bigger. Do it with a pentagon. And I could do it with a hexagon, right? And you could go on. So I could do like maybe, oops, that looks terrible. Do an octagon. 3, 4, 5, 6, 7, 8. And you can see that the polygon, the more sides the polygon has, the closer it's going to estimate the area of the circle, because this gap is getting smaller and smaller and smaller. So we're going to do that. Let's first do that for a hexagon, because then we can kind of see what we're doing. There are like formulas for this, but we don't need a formula. So first, for a hexagon, we have a regular hexagon here. So what's nice is you have 6 triangles. They're all the same. Let's just look at a circle with a radius of 1. So let's look at that. Radius equals 1. Okay, so we have this radius is 1. That means this length is 1. Okay, so if I blow up this triangle inside, have a 1 here, I can drop not a hypotenuse, drop an altitude. I can see this, and I would need, if I had this area of this triangle, instead of 6, I need times 12 for the area total. Say, well, if that's 1, well, this is a right triangle, and this is 30 and a 60, 90 degrees. So I actually know this is a half. And from the Pythagorean theorem, I know that's square root of 3 over 2. So to find the area of that, I would say it's 1/2 base, which is 1/2, times height, square root of 3 over 2, right? Base times height. Then I need 12 of those to get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, times 12. Okay. And then I would simplify that, 3, and I end up with 3 root 3 over 2. I can calculate that. And I get 2.59. Okay, so 2.59 would be the area of this, or 2.5 units squared with the radius of 1. Now we know, or so we've been told, that the area of a circle is pi r squared, and our radius is 1. So our area of this should be pi units, which is 3.14 units. We got 2.59. It's obviously too small because we also know, though, that this shape was not marked. Okay, so we're going to try it with a larger number of sides on our polygon. Let's erase this. All right, so I'm going to definitely draw this out of proportion because I want to be able to see what I'm doing. Okay, so here's our circle. Here's our circle. Okay, and I'm going to put an n sides. So I don't want to do it for 10 sides, 20 sides, because I'll have to do it over and over again. So I'm going to think, okay, if I just had n sides, and I'm going to decide what n is later, I'm going to kind of figure out an equation based on that n, so I can pick a different n and find the area. So let's just pretend this is some n sides. I don't know, but this is hitting here, right? And I'm going to kind of blow up the bottom piece. Just pretend that this piece is really small or really big, depending on what your N is. I just want it big enough so we can see and write in the space of the angle. So really your angle might end up, N is bigger, it gets smaller and smaller, but I'm not going to be able to fit any words in there. So yes, this is totally out of proportion, but don't worry about it. So if I have N sides, that means whatever area I get of this triangle, I'm going to have to multiply by N. So don't forget that. So we'll write area of one triangle multiplied by N is the estimate for the area of the circle. Okay, let's just get that down. Okay, so we don't forget to multiply by the end. All right, so we're still going to say this is a radius of 1. Okay, well, that 1. Well, if that's 1, I can still do the same thing I did with the hexagon. I have a right angle. Okay, if that's 1, this is not going to be 1 over 2 because that wasn't a 30, 60, 90. We could figure out what this angle is, though. Here we go. Here's an angle. We know that there's 360 degrees all the way around. So if I have N triangles, I know that this whole angle, this one, is going to be 360 over N. So that means half of that angle, this one, is going to be 360 over N over 2, which is 360 over 2N, which is 180 over N. Okay, so this angle here is 180 divided by N. So if N is 10, the angle degree is 18. If N is 100, it's 1.8. Okay. And then we have, this is 1. And so what we really need is the base and the height. So I'm going to redraw it here. Have this triangle here. Now this is half of the whole one, so we're going to need to multiply this, multiply by 2N at the end, because we're going to have, there's 2 for each side. And I need my base, and I need my height, and I have an angle, and I have an angle, 180 over N. So that means I can use some trig. Oops. Okay. And I can solve for the other sides. All right, let's think about that. I know that the sine of this angle is the opposite, b over the hypotenuse. The cosine of this angle, cosine of 180 over N, is h over the hypotenuse, which is 1. This is 1. Okay, because that's the radius. And maybe we could switch that to r if we wanted to, but we're not going to do that yet. Okay. Now, okay, well, that means that b equals sine of 180 over N, and h equals cosine of 180 over N. So actually now I can find an equation for my area. So I have the area of this polygon is 2N, because I need 2 of these triangles, or 2N triangles, times 1/2 base, which is sine 180 over N, times the height, which is cosine of 180 over N. Okay, and then we could simplify a little bit. This is nice, this goes away. And then we have N times sine of 180 over N, and then times cosine of 180 over N. And this is all, of course, assuming the radius is 1. So let's just think, what is sine of 180 over N? If you kind of look at trig, let me just do this real quick. The period of sine is 2 pi. Pi is here. This is 180. So the sine of 180 is 0. but then the sine of 180 over n, let's just think about what happens when n is really, really big. Well, like if n is 1,000, this is really close to 0. And if it's 10, 20,000, it's even closer to 0. So it's kind of like you're taking the sine of 0 almost, right? Which would just be 0. So let's just think about that. If n is really big, this is like 0. What's the cosine of 180? Let's see. Think cosine. Oh, I could have done that in different color. Let's just do cosine different color. It's like here, here, right? So cosine of 180. Now, if n is really big, oh no, we don't need cosine of 180. We need cosine of 0. Here we go, is 1. So as n gets really, really big, if you say cosine of 0, it's going to be 1. So you're basically saying, what happens if we multiply if n gets really, really big, right? We would say this is like infinity, then this is going to be like 0, and this is going to be like 1, right? So we're basically kind of getting things close to infinity times 0 times 1, maybe not. And I'm going to tell you, well, right now that actually is pi. So individually, as n goes to infinity, n is infinity. Individually, this goes to 0, and this is going to be 0. And individually, the limit as n goes to infinity of this is 1. So these limits are individual. But I doubt anybody would believe you if you said infinity times 0 times 1 is pi, which is I'm going to show you. Okay, so let's just get rid of that because people think we're going to be crazy if we do that. So let's just come over here, and I'm going to just pick a number for n. I haven't even done this yet, so I'm going to pick a fun number. How about 1,000? Okay, so I'm going to pick n equals 1,000. So on my calculator, I need to write 1,000 times the sine of 180 over 1,000, which is actually, let's just say 0.18, times the cosine of 0.18. Let's just do that. With me, so you know that I'm not cheating. Okay, 1,000 times the sine of 0.18 times the cosine of 0.18. I've got 3.1415, which is not very good, right? 3.14157198. Well, we all know that pi is actually 3.141592. So this is too low, which is a good sign. We know it's too low because it's a polygon with 1,000 sides inside a circle, and there's like a gap here. We should never get above pi, or else we did it wrong. Okay, so let me just grab my pi book real quick. Okay, so this is a book my mom got me for Christmas, The Joy of Pi. And this book says, by Simon Newcomb, quoted in The Mathematics and the Imagination by Edward Kasner and James Newman, 10 decimals are sufficient to give the circumference of the Earth to a fraction of an inch, and 30 decimals would give the circumference of the whole visible universe to a quantity imperceptible with the most powerful microscope. So we know we're never going to need more than 30, I hope, unless you're super smart. But we might need 10. We have 1, 2, 3, 4. We only have 4, so we probably should get a couple more. All right, that's easy enough. Let's just, I don't know, add 3 more zeros. There. So what do we got here? 1, 2, 1, 2, 3. So I basically did a million. 1, 2, 3, 4, 5, 6. We are going to say the sine of, let's see, 180 over a million, which is 1, 2, 3, 4, 5, 6, 2, 3. So that's 3 zeros. Okay, so 0.000180. Oops, let's do 18. 1, 2, 3, 4, 5, 6 times the cosine of 0.12318. All right, let's see what we get there. Just for fun, okay? Calculator, clear. Okay. I'll just do sine and cosine first. Let's see, no. 1, 2, 3, 4, 5, 6 zeros times sine of 0.123 zeros times the cosine of 0.123 zeros. What is this? Do you see that? Can you see that? Maybe you can't see it. 3.141592654. So we're at 92654, which means the calculator really just rounded. Okay, so what we know is if I just plug in a million-sided polygon into a circle, I got pi accurate enough. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to calculate, what was it? The circumference of the earth to a fraction of an inch, which is probably more accurate than I would ever need, considering the earth isn't even round and we have mountains. So there you go. We found out what pi is. We found out what infinity times 0 times 1 is. Except, just kidding, right? Limits are weird. You'll get that in calculus. And yeah, we just use area. That's all we did. So anyway, a lot of people ask, how do you find pi? What is pi? I don't know. It's just a number. It's just a number. We just happen to come upon it. And all we know is the ratios of triangles. That's it, an area.